Hi guys, in the last video, which is linked there, we looked at a chess game, and we got our images and we serialized our data for our sort of base game, our sort of starting state, if you like, so where all the pieces are. And in this video, we are going to deserialize that data and place those pieces on the board inside the world, and we're going to try and get that done all in less than an hour. You know me and my long videos. Sorry folks. I'm recording this over an entire day. Anyway, doesn't matter. After the fade. So this is where we left off last time. We have our serializer, we have a debug application, debug script application. We have a debug script, and all it does is it creates our default save game. But we want to be able to load that save game back in, and then we want to display that information. So what we're going to do is we're going to back to our chess serializer, and you see that this is where our save game is. So all of this we're going to take out and we're going to put inside, we're going to refactor this and put this inside one function. So I'm going to call this function public. We don't need public, we need string get save location, and I am going to take all of this out and I'm going to paste this in here, and then I'm going to do return full path, and then I'm going to say I might be up to get interrupted again. So our string full path is going to be path equals get save location. Okay, and the reason I want to do that is because I want to have a load game that takes the data, that gets the data from the serialized file and then creates our board game from it, or board from it. So I'm going to do public board load game. And I don't need a path because the path is going to be set in stone to be this location here. So our string full path equals get save location. So we have two choices here. We either have the file exists, or the file exists and we load it, or the file doesn't exist and we return a new board. Okay. So we can check to see if file exists, full path, to do load file, else return create new game. Okay. So right now we've got a red squiggly line in because not all code paths are going to return something at this stage, and it will tell you that here not all code paths return a value, so we're going to have to fix that. So if the file exists, we're going to have to do our JSON thing in reverse. So we load all the text first of all, file dot read all text, and the path is full path. And then we're going to create a board from that, which we don't need. We can actually just return it back out here. And then we do return, and then it's going to be JSON utility from JSON, and then it's board, and then JSON string. So that will then load everything in there, or it will return just a blank game. So we didn't really need to do the save game thing, but I'm glad we did the save game thing because now we have our test data stored there. Okay, all right. So now we need to create a class that will then take a board and then create all the pieces from it. Okay. All right. So each piece is a type, each piece has a position. Okay. So, okay. Okay, let me just think here. What is the best way to do this? Well, what's a way to do this? Let me remind the best way to do this. I really want to have something that's got our pawn, knight, rook, bishop, queen, king. So I want to have that functionality in there, and I want to be able to choose different colors or whatever it is I want to have for our pieces. So I think I'm just going to go with a sort of basic thing just now. So if I go to here and do our, what are we going to call this? Board renderer. Board renderer. It's a rather highfalutin name for what it actually is, but never mind. Okay, oops. Save that there, save that there. All right, so our board renderer is going to take in, a board, and then it's going to display the pieces on the board. So we need to know what shapes, what sprites we're going to use. So I'm just going to do this brute force just now. We can change this at some point later on, but this is really about serialization rather than about how you organize these particular values. So I'm just going to do public black pawn, oops, sprite black rook, bishop, pawn, rook, bishop, knight. I suppose you should do them in kind of order, but Okay, so that's the black pieces, and then we're going to do exactly the same thing, but for the white pieces. There is a great way to do this. If you hold down the Alt key, you can actually block out a rectangle, and then whatever you type in there gets duplicated across multiple lines. So you can do this anywhere, by the way. You can just make out that, because otherwise if you don't have the Alt key, you can see that it just selects the characters basically in a row. So hold down the Alt key, select everything up to highlight the entire word of black, and then type in WHITE. And you see that we now have the same values, but this time for the white pieces. So our board renderer, I'm going to put this on our debug chess object. Board renderer. And you see that we have our black pawn, rook, bishop, knight, blah, 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 blah. And then we're just going to copy these values across. So I'm going to choose, black's not really going to show up against our board here because our board is actually black. So I'm going to choose red for our black pieces. So our red pawn, our red knight, there's our bishop, there's the rook, and here is the queen, and there is the king. And then we'll do the same thing for the white pieces as well. So we have our pawn, we have our knight, we have our bishop, we have our rook, and we have our queen, and we have our king. There we go. And then we have public void so we're going to initialize our board with our initial pieces, and all we're going to do is we are going to I think what we want to do is we want to map these values to make it a little bit easier for our serializer. So let's leave our public initialize just now, but I also want to create a dictionary string, and I want to link that to a sprite. So I'm going to call this sprites. And you see the dictionary's got squiggly lines against it. That's because it needs a generic collection against it. Okay. So what I want to do is I want to map small p to this sprite here, small r to this rook, and large capital P to pawn, capital R to rook, white rook, and so on. And the way I do that is I'm going to do void awake sprites equals new sprites. And then I'm just going to go through and cycle through all of these values. So I'm going to say sprites pawn equals black pawn, sprites rook, black rook, sprites. Okay, so there's that there, and then I'm going to do exactly the same thing again, and I'm going to copy and paste that in there. And again, I'm going to do my alt trick where I highlight the rectangle and I'm going to choose white, and then I'm going to change these to capital letters. So P, R, K, B, Q, K. Okay, so all I've done is I've done a map between my my pieces, my piece types, which is serialized out. So it's got our P or R or K that we set up inside our chess serializer, and I'm mapping that to the physical representation, what it's going to look like on the screen. And then for my initialization, what I want to do is I want to create a new game object with a sprite renderer, and then set the sprite renderer to be that particular type. But really I should probably create a prefab, so that's what I'm going to do. So I have, let's create a 3D object, sprite. So let's create a sprite object. Okay, so our sprite object is going to be called chess piece. Okay, we're going to change this anyway, it doesn't matter. Chess piece, and it is a sprite renderer, but it has no sprite attached to it, and we're just going to put it at position 0, 0, 0. So it's basically going to be at this point here, but there's no sprite attached to it. And what we're going to do is we're going to create a game object that's going to be called whatever the name of the type is. We're going to use that there. So you're going to see like lots of P's and lots of small R's and all that kind of stuff. So that's our chess piece there. And then for our board renderer, you see we have all these values here. We're also going to have a public game object piece template. So this is going to be our piece template. So if we want to do something special with our piece, then we can create, we have this piece template that we're going to use, which is our prefab. So we're going to drag our chess piece onto our piece template. And this is what we're going to create. We're going to create this, access the sprite renderer, and then use the sprite renderer to display our object. So initialize. All we need to do now is we just need to go through all the pieces in the board and add a new game object based on that particular piece. Okay, and we're going to tidy this up in the next episode because we really want to, when we initialize it, we want to delete all the objects that we created before. In fact, you know what we want to do? We want to actually have, we really want to create 8 plus 8 plus 8 plus 8, which is 32 game objects that we're going to reuse for each, that we just reuse. So let's do that instead. So we have our piece template, and then we have up here we're going to have game object, and we're going to call this pieces, and pieces we're going to initialize to be a new game object, which is, like I said, going to be 32, because there's 8 pawns for each side, and then we have our back row of the nobility. So that's 8 plus 8, 16, plus another 16 is 32. So that gives us our 32 game objects. So for each of these game objects, we are then going to apply those values here. So now bearing in mind that we can't have more than, well, I guess we can have more than, can we have more than 64? No, we can't. We can't have more than 32 pieces on a chessboard. If I'm wrong, write me below, but I'm pretty sure we can't have more than 32 pieces on a chessboard. So I'm just going to do for I, int I equals 0, I less than board dot pieces dot count, I plus plus. So for example, if we decide that we're going to load in a game from the Times crossword, the Times puzzle page has a chess problem in it. Let's say we load that into memory, then it only usually has like an end game. So it's like 3 moves to checkmate. There's only going to be a handful of pieces on there. So this will fix things up. What we maybe want to do is to do clean up pieces and move them off the board. So maybe we want to move them off the board some point later, but I'll leave that just now. So the reason why I'm doing this is because we know there's only going to ever be 32 pieces on our chessboard. So we don't need to allocate any more. We can actually just say we are always going to have 32 pieces. So this means that our memory allocation is going to be fairly straightforward. It's going to be 32. We're going to have 32 objects no matter what game we're playing. We're always going to have 32 objects. Or less, but we might have less than 32 objects on the board, but we're always going to have 32 objects in memory, which is not a lot. Okay, so for each of these, we're going to say that remember that just allocates a space for our game objects. So this is going to be null. So we're going to say if pieces I equals null, then we're going to create a new game object. Pieces I equals new game object. Pieces, I really cannot type. Pieces I dot name equals, and then we're going to call it whatever the name of the piece is. So it's going to be board dot pieces dot I dot type. Okay, and then actually we don't want that inside that if statement. We actually want that outside the if statement. So we're going to set the name of the object. So this is us just saying that if the object at this position inside our array is null, then we want to create a new game object in there, because this is just allocating it. It doesn't create a new, it doesn't create 32 new game objects. It just creates space for 32 game objects. So in here we want to say if that slot is not filled, we want to add an item to that object. Then we want to set the name for it, and then what we want to do is we want to access the sprite renderer. And we want to say the sprite is going to be, where are we? Our sprites. And then it's going to be our board. Actually, let's cut back on this a little bit. Actually, it's going to be pieces.name, isn't it? Because it's our type. So our type, remember, is going to be our pawn or rook or king or whatever it is. So we just do that there. And then we're done for naming it. So we're saying that our sprite is the name of the sprite in our dictionary. So this is our map between our P, our R, our K, our B, our Q, our K. And then we just need to do our transform, which is going to be our transform.position, which is also stored inside here as well. So we have pieces i.transform.position equals board.pieces i.position. Okay. All right. So just to go back through this again, we have our awake. So this is like our constructor in Unity. So we create our dictionary that maps our piece type to the actual physical representation. So although it says black pawn, black rook, black knight, we can actually specify that it's going to be a red pawn or a red knight or a red bishop. And similarly for the white pieces there as well. And then we allocate an array of 32 to our pieces. These are our instances. So we know we're never going to have more than 32 in this particular game anyway. And then we're going to create a public, we also have our template as well. So our template is actually, well, okay, made a bit of a mistake. So it's not game object, it's actually, we want to instantiate this template here. So instead of new game object, we want to say instantiate, and then it's the original object. So we want to make a copy of our object, because we might want to do other things with it, like tidy this up, because it'd be nice to pass in just a piece and then let it figure things out. So we'll maybe do that in the next video. Okay, so we have our piece there, we instantiate it, and then we set the name of the piece, we get the sprite renderer, and then we assign it to our dictionary of sprites. We use this, the name of the piece, to access that value in there, and then we set the position there. Okay, so that's everything done there. So the debug now, we need to say void button load game. So we haven't created this yet, but we're going to create this. So board loaded game equals serializer dot load game. And then because debug is attached to the same object as board renderer, I'm just going to say get component board renderer initialize and then pass in loaded game. Okay. And I'm going to create a new button just by copying the old one. And I'm going to change the name of this to load, and I'm then going to change the, you see that it says create button here, so this is another reason for copying it, is that I've set this part up already, and all I need to do is just change it from debug button create to debug button load game. And I think that's everything done. So I've created that there, hooked that in there. Our debug chess has our board render, which also has a chess piece. All these pieces are set up, so yeah, let's play the game. Well, let's load things in here. So create is going to create our game, so that's going to give us our default pieces and then load should load everything into memory, and you'll see that hopefully, fingers crossed, when we run this, we'll see a whole slew of objects getting created here, and we should see the values getting populated here. So let's see if that works in 3, 2, it's very exciting, isn't it? 1. Okay, not quite. We're missing a whole bunch of pieces here. Because it says the key was not found in the dictionary. Well, that is not good. Okay, well, let's see why that is. So we have type K, type Q, knight, queen. Okay. Okay. What we can do is we can say if, so this is us debugging it now, if sprites contains key pieces I.name else debug.log can't find piece of type oops. Well, it looks like we might be, yeah, that would be Unity engine debug.log. Okay, it looks like we might be having to do some debugging here. Okay. Load. Oh, you know why? Because I think I put the wrong values in. Oops. So it's not lowercase k, it's lowercase n, and it's uppercase N for that. That's why. Let's make sure I've got that right in here. Yeah, I have. I've got lowercase n and lowercase n. Oh, silly mistakes. Well, this is why pencils have erasers. So now when we load this, this is our chess pieces. This is exactly what we wanted. We have our chess pieces here. So we have our queen, our king, the rook is all there. Everything totally serialized, totally deserialized. We now have everything loading from memory. And the great thing about this is that when you take that away, your scene is no longer cluttered. It doesn't have all the junk in it. You don't need to have 50 pieces in there. It's all coming from the data. It's not quite, but it's getting there. It's almost data driven. So yeah, so I think we will we'll stop that there. It's another successful way to deserialize data. So that's us deserializing multiple positions and multiple object types into disk and then from disk. So there we have it, serialization, deserialization. Make sure you get the chess types right. Remember, it's N for knight, not K for knight. K is king. Yeah, rookie mistake. If you like this video, please give it a thumbs up. If you didn't like the video, then thumbs down. But let me know in the comments below what's the room for improvement. Less stuttering and less umming, I guess. I just did it there. Can't help myself now. Thank you very much for your time. I know time's important. So until next time, thanks for watching. Bye.